that when we make the substitution, we need to be careful about the limits as well, because these limits apply to the variable x. If we change the variable u, we have to change the limits as well, okay? But to start with, I'll just leave the limits off, just to make things a bit easier, maybe. So integral of dx over x ln x, using substitution u equals to ln x, so we clearly always just take the derivative of the substitution. A bit of rearranging, and there's different ways of doing the substitution, but my rearranging is that because I see dx upon x here, and I see dx divided by x here. So that's how I'm going to make the substitution. So now the integral is dx upon x, which is just du, and 1 over ln x. Yeah, so this is just 1 over u. And we know how to do that. The integral of 1 over u is ln u. So the answer is actually ln of u. Put a little bit absolute value signs around it as well. That's okay. But this is quite interesting because u is just ln x. So we can actually put it back now into the x variable. And I'm not going to change the limits because I'm going to have it as ln of x. And now I'm going to put in my upper and lower boundaries, which is e squared and e. So if I continue up here, let's see what that looks like now. It'll be quite interesting. Equals the natural logarithm of e squared minus ln of e. Okay, so you have to know your logarithms here. So I'm just going to put a little base e here just to make it a little bit clearer. So I'm looking at this, it's the base is e. E raised to what exponent gives e squared? Well, that's clearly 2. So this is now ln of 2. And this one here, what exponent do I raise e to get e? Well, that's 1. So that's ln 2 minus ln 1. But ln subtract ln is the same, isn't it, as ln of 2 divided by 1, which is just ln 2. Alternatively, what exponent do you raise e to get 1? It's 0, so it's ln 2 minus 0. The final answer is just ln 2. So notice I didn't change the e squared and e limits for x into the limits for u that you could have done, and you could have then just answered directly from here.